Hello everyone, Tony here, and in this video I'll be taking a first look as well as doing a tutorial and maybe a teardown of this 15W RGBW LED par can. Now, one of my most popular videos back in the day was my unboxing, first look, and teardown of this 18W RGB LED par can. This contains 18 1W LEDs in a red, green, blue formation. This is more like an updated version. This one I think I bought for about 25, maybe 30 Canadian dollars back in the day from, I believe, AliExpress. These ones are much cheaper now. This one you can get for as low as $8 US or like 12 Canadian dollars on sites like AliExpress. And at first glance it also looks like it's much more compact than the older models. The density of the LED is much higher. Like this form factor I've seen more often used for like the 30W versions where you have a higher LED density. So this one is definitely a lot more closely packed, and as well it also features a third color. In fact, if you look closely at the LEDs, you can see how the center three have that yellowish glow where the other ones don't. So the center three are the white ones. So let's take a look. I do appreciate, I guess, a smaller form factor. Now, on the stand, this one had a two-ring stand, which meant that you could like prop it up, put it on the ground, and have it like at an angle. This one looks like they've gone for a single U-shape, so you'll have to, like, it's fine I guess if you wanted to mount it on a T-bar or something, but apart from that, putting it flat on the ground is not happening. With some of the bigger ones, it's like this. I know, like, some companies, I know ADJ on quite a few of their par cans puts it such that you have power in, power DMX and DMX out on the side, and that way you can place it flat on the ground, not with this. So on the front we have our 15 LEDs, as promised. On the back, let's zoom in a bit. I apologize for the constant autofocus noise. Since we're here, we might as well lock the focus. We have DMX in, DMX out. In a follow-up video to this, I'll show you how you can control DMX lights for cheap from your computer. Essentially, if any of you are curious right now, you can get any. There are a bajillion adapters that contain the UDMX, like micro DMX chipset in them, and there are a bunch of program software. For example, QLC Plus, I believe, is a rewrite of the original QLC, and it is freely available as it is a free and open source program, and it works quite well. It lets you have virtual control panels, save scenes, program entire shows. That works very well. In fact, I'd like to make a video on that software alone because it's very impressive. On the top we have the power input, DMX in, DMX out. Similar to the old one, looks like we have the 4-digit 7-segment display, still with the protective sheet on it, and menu up, down, enter buttons, as well as this very high quality and definitely very well applied sticker from the AliExpress store you buy it on. So I guess let's plug it in and take a look. I'm assuming this uses a pretty similar chip to the older version. Now they do make multiple versions of this. They have bigger ones. In fact, they have ones that are in the form factor of the older one but contain 7 like RGB, like tricolor LEDs, where each LED itself is multicolor, whereas this one is individual color. So let's plug it in and just boot it up in DMX mode because that's where I was using it. The menu is very similar. In fact, let's go over it. First, you have the manual RGB modes. Oh, and you can see that the display is very definitely multiplexed. There are different pages in this menu. To switch between the pages, you press the menu button. So you have RGB, white, flashing, direct color, color changing. This is other, like color fading, individual like color pulses, sound based, as well as A, which apparently stands for DM. And we're back to R. So here you can then change the different values. For example, each one you can interact between 0 and 255, except for DMX, which goes up to 512 if I am not mistaken. So for example, you could set RGB, you could have your white be on, off or on, so on and so forth. But for example, you might be tempted to, say you leave it in DMX mode, right? And then you unplug your light, plug it in, and you'll see that we're on a different page. This is the white page. Well, that's because the last page you're on is set by pressing this enter button. So when you press this, you'll notice it says save. So now, say I set R to 0 and I saved, unplugged, plug it back in, and we resume here. But if I was to raise it to 255 and I don't save, I unplug, we'll be back to 0. So press save when you want to write to memory which mode you want to turn on with. That being said, we can then take a look at the actual modes. So let's set it to RGBW. Let's set everything on. And here we go. This is going to kill the exposure. Yep, it is. You can already see from the camera that the red looks a bit darker. So let's point it like this. So the individual RGB controls are pretty straightforward. So for example, say I had white on and I wanted to dim the white, but not turn it off. Well, we can bring it down. Say we wanted to bring it down to a lower value, and now you can see that the whites are of a much lower intensity, although it's not as easy to see on the camera. It's very easy to see in person. Yeah, there you go. See, now you can see that the whites are very much dimmed. I do appreciate that it has white built in though, because one of the complaints about the past versions was that RGB LEDs tend to look wonky. For example, I'm going to do it, this is with just the red, green, and blue, and I'm going to hold it onto this paper. And if it doesn't wipe, let's lock the white balance, and we can see that you get that weird, it looks like fineish now. It does look a bit blue because the red is dim. But the moment you put something in front of it, you'll notice that you get these multicolored shadows, which is not very visually appealing. Also, you'll notice that stuff like skin tone looks way off. Technology Connections has an excellent video on this topic called The World in RGB. I would highly recommend it if you're interested in stuff like this. You check that video out. Next we have flash modes. So what the flash mode does is it will basically flash whichever color you set at a variable frequency. This being the fastest, and slowing it down. For example, it works with the RGB though. So for example, if I wanted the color blue, I could do this, and when I bring it to the flash mode, you'll notice that it is the color blue that flashes. So it uses whichever color you set in the RGB mode in your strobe mode. Nice. Now next is the color menu. So we have a couple options. Oh, you can see that very nice multiplex display right now. So we have color 1, which is red. You can see the 3 red LEDs. Color 2, green, 2 green LEDs. 3 blue. Color 4 is the 4 white LED, sorry, the 3 white LEDs. And you can see that if I just shine the white LEDs, I mean, they're not the world's highest CRI LEDs by any means, but it looks a lot better than that weird RGB, because if I put my hand out, now we don't get that weird multiple shadow nonsense. If I do this with my hands, you will see that it is very much using PWM to dim the LEDs. Not sure how much of it comes across on video, but you can see your fingers look a little choppy. Again, probably not the best CRI. It's probably, these actually do look like pretty good, 5500 Kelvin. Next we have other colors. So color, that was color 4. Color 5 is all of them on. 6 is just red and green. 7 is red and blue, so this would be like a yellowish. Doesn't look very yellow because the red is dimmer than the green. 7 is this purple, actually looks pretty good. Then we have green and blue, cyan. I'd also say that this looks pretty nice. And then color 9, which is red and white. 10, which is green and white. 11, which is blue and white. And 12, which is all of them, even though there is already a color with all of them. In fact, it is color 5. So there are two color profiles that turn all of the LEDs on for some reason. Now also we can see that the red LEDs are they're doing that, so just by looking at this I already know this is going to follow the same fate of the other one, which is die in a couple of years. Because I can already tell what's happening is they're not doing any current limiting on the LEDs of this. Rather, they are using PWM to bring down the average current going to the LEDs to their nominal amount. Now this means that unfortunately the lower current voltage LEDs, such as the reds in this are probably like red LEDs are usually a lower voltage than green and blue ones because you need a lower current to drive them. The red LEDs are probably going to end up burning up on this as well, followed by the other LEDs pretty closely, which is very unfortunate, but that's the way these Chinese ones tend to go. Now, one of my biggest concerns with the 18 watt Parkin was how freaking loud the fan was. For example, if I was trying to record a video, I would not even dare put it in the background or something because of how loud the fan is. For example, you'll see that, one of my biggest complaints about this light was this very noisy fan. And if I plug it in, you'll see exactly why. So let's plug this in. Now if I plug this in, you'll get us the beautiful so let's unplug it and plug it back in and you can see the noise. Here it is with the fan unplugged. Here it is with the plug plugged in. That is an awfully noisy fan. It makes that horrifying screeching sound. I'd say is the fan on this is notably quieter. So if I plug it back in, it's a lot quieter than the other one. If I bring it close to the mic. One of the biggest complaints on my last video was that people couldn't accurately make out how loud the fan actually was. So this time I'm going to do it right, and I'm going to record straight with a microphone that isn't a camera mic, just so you guys can get a good perspective. Here it is, before it's plugged in, and this is a very directional microphone. There's more noise when it's upside down. I would argue that that is acceptable. Now the high frequency interference noise is also interesting because this is on a balanced mic. It shouldn't be picking it up from the wire, so there's obviously some source of electrical noise. There's still that fan noise, and it's still very audibly like an 80mm or like 92mm fan. But it's nowhere near as loud as the other one. One, because it's not as loud, it's definitely a lot quieter. And two, because it doesn't have that screeching high pitch to it. If you have this facing upright, I mean it's also on the carpet, which is absorbing part of the noise. But this is producing less noise on my desktop right there. And let's finish taking a look at the modes. So after color we have this, which is CC, which is color change. So this jumps between the colors. Now it jumps between the colors that you saw. So the other one would go red, yellow, green, cyan, blue, magenta, red. This one instead is following the weirder order where it's going red, green, blue, white, and then all. And also, here's one thing you can notice. If you look closely at the brightness of the LEDs, I'm not sure if the camera picks this up, but there's definitely some current issues happening here. For example, the white LEDs in here are bright, and in the moment all of them come on, you can very visibly see those LEDs dim up. Just like that right now. So for example, take a look at the white LEDs now versus here. You know, they're a lot dimmer. And for example, when all of the colors are on, take a look at like the individual color LEDs. So take a look at the reds, and you'll notice that the reds suddenly got a lot brighter. Same here. Take a look at the red, whoop, and then suddenly you'll notice it's gone a lot brighter. So what this tells to me is it doesn't look like there's enough current or there's enough wattage going around to actually power all these LEDs, because we're seeing the brightness on them drop when all of them are turned on at once, which is not a very good sign. But we'll take a look. So the speed of this mode is also adjustable. So higher number means faster changing colors. So if I go up to like 95, you'll see, okay, it's going plenty fast. And if I go back, it's going painfully slow. The next mode is this smoother color changing, so if I increase the speed, you'll see what's happening. Now again, instead of going between fading red to green to blue, it fades between its individual color modes. And here's something I've also noticed. If you look at the dimming, this will be hard to see on the camera due to the flicker, but I'm going to slow it down just so you guys can maybe appreciate it as much as I can see. The green LEDs go up and down very much in more stages. They don't have as wide range. For example, the blues look perfect. Like, you'll see that when they're dim, you see that they jump a lot between the brightness levels. But you can especially see with the red, like 1, 2, 3, 4, 5. I can basically count the brightness levels. And when the red fades out, you'll see it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9. You can like see the stages with the red a lot more than with the green. Like with the green, you'll see that's like it's suddenly going up. With the red, you can kind of make out like the individual steps it's doing, which further goes into my theory that to do current limiting, they're just limiting the PWM range of the red. So while the green, blue, and the whites probably go from PWM 0 to 255 or whatever, how many bits their controller has, it looks like the reds are probably going from like 0 to 50 or like 0 to 100, because if you increase it any further, you're going to burn the LEDs because you're going to exceed the maximum current rating. I'll leave this on in a minute so you guys can see the different color patterns it goes through. So here are the individual color stages it goes through. I'll let it cycle around at least once. And I'll also shine it on the paper so you guys can take a look at how that looks. RGBW. Wow, thank you, autofocus, for being especially noisy today. Cool, I'm gonna start it back and shine it onto this piece of paper. There you go, here's how the effect looks. So you can see going between RGBW, going through the various colors. And the color order it's going through is a bit wonky, but other than that, it actually looks pretty smooth. Red, green, blue. Yeah, I'd say that the color grading looks pretty smooth. Overall, I rate it pretty good. Next we have this individual colors. This is basically where the colors fade on, then fade off, then fade on, then fade off. I'll just speed it up so you guys can take a look. These color modes are pretty much exactly the same as the old one, where you had the RGB, and then you had individually setting the values, and then you had the strobe, then you had, in that case, DMX, then color jump, color fade, and then this individual color fades on, then fades off business. The only difference I see is like this one puts DMX at the very end and labels an A instead of D. I mean, I guess A makes sense because it stands for address. That would actually make a lot of sense, A for address. Whereas the other one had D for DMX. The final mode is sound active. The sound mode on this sucks. If you were playing music, it wouldn't trigger. You basically have to, like, even if I'm tapping the enclosure, it doesn't trigger. You have to tap it real hard to get it to change color, so the sound mode is very much useless. Now there's different sound modes. If you have it set to like SO1, it always turns on red, which might be what you want, which might not be. 2 always turns on green, always blue, always white, yellow, so on and so forth. You can set it to change color, but the last sound mode, which is sound 9, I believe, is probably what you want. That's one where it changes colors when you when it hears music. Finally, we have the A mode, which is once again address for DMX, and I'll show DMX programming in another video. So that's it for the overview. And look at the different modes of operation this has. And don't like the comment, for example, I have other like quality concerns, not just the dimming of the LEDs. For example, this cable. This is way too flexible to be copper. Here's a copper cable. It's like notably stiffer. It has that like rigidity to it. This looks like a very, 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 very flimsy cable. This is probably aluminum and not copper. I don't even know if that's legal in, I will say, electronics. And the second thing is I was going to take this apart to show you, but it looks like in this newer version, I do not see any screw holes in the front. So I'm assuming this is a clamped together design. You know, Big Clive has already taken apart hundreds of these, I swear, and it's uses a very similar switch mode power chip, usually one where the AC-DC isolation is not very good because they tend to put like the opto isolator, breaking up the PCB, so on and so forth. Other than that, they're decent switch mode power supplies. Also, the LED plugs don't have the progs, which is very unusual. Just like how this latest hard drive I got from CA is shipped with this power supply that doesn't have the holes. That's very unusual. Usually it has that little notch, like little hole, so that the notch in the socket can at least hold it in so it doesn't fall out as easily. Anyway, that is all for today's video. This has been the first look tutorial, I guess, as well as demo of this 15W RGBW power can. And I mean, overall, if you just need something for like a single party, it's a lot more compact than this. It has those white LEDs, which is a plus. Maybe not quite as bright. But overall, I'd say it holds up much better than and more versatile than the 18W version did. Now, as I said, if you're buying these, like if you just want it for like your man cave or something, I think it's absolutely like the quality is acceptable. Just know that if you are an actual DJ and you're going to be using these for bigger events, these LEDs are going to die, which is very unfortunate. So these are basically disposable in that regard. It's going to die in a couple of probably sessions. In fact, I don't even know if I would trust this on a DMX network because I'd be worried about receiving live 120 volts on my computer's USB input, or on my, say if you're using like an expensive like ETC board or something. If you have like an ETC Ion, I would fear for my life plugging this in. Like this will blow up your $5 lighting board faster than you can unplug it. So yeah, that being said, for individual purposes, works pretty well. And at this point, I'd like to thank you all so much for watching. I think this video has gotten much longer than I initially wanted it to be. But I've addressed some of the concerns. Fan noise is a lot less. That's great to see. Yeah. This has been the first look review, whatever. Not review, I'll do a long-term review when I've had this unit for probably a year. We'll see how quickly the LEDs on it decide to burn up. Thank you all so much for watching. Have a great day. Bye.